conditional permutations today. So tell me, what does it mean when somebody places conditions on something? Maybe you asked to do something this weekend and your parents say, okay, but there are conditions. What does that mean? What does it mean to place conditions on something? What do we got there, Elizabeth? Some kind of restriction. So maybe your parents say, yes, if you finish all your homework, or if you clean your room, or if you do these other chores, or things like those lines. Anybody ever have parents giving answers like that? I sure gave answers like that to my kids a lot, and my parents did to me way back when. So today we're going to talk about permutations. We want to arrange things, but there are certain restrictions. Up to now, we've dealt with one kind of restriction. Sometimes we've said it's not okay to repeat a number if you've already used it, or to repeat a letter if you've already used it. So we know how to do that kind of restriction. Today we're going to talk about some extra ones. So this one says we can't repeat. We know what to do with that. What's the other word in there that gives us another restriction on the kind of numbers we can form? Chloe? Even. So we need to have even numbers, and we can only use 7, 4, and 8. So if a number has to be even, is that a restriction on the hundreds digit, the tens digit, or the ones digit? Aiden? That's on the ones digit. So we are going to start with the ones digit because it's the one that has restrictions. So I'm only allowed to use 7, 4, and 8, and it's got to be even. So what can go in that ones place? What are my choices? Okay. 4 and 8 are my only choices. So how many choices does that mean I have for the ones digit? 2. No particular restrictions on the others, so it doesn't matter which one I do first. But when we have a restriction, we want to try to start with the restriction and not just go left to right. Once we've taken care of the restrictions, we can do any order. So I don't know if I just used 4 or 8, but I put a number in the one spot. And let's say I decide to fill the hundreds next. How many choices are left? 2. I've picked one number. I just don't know if it was 4 or 8 yet. So I've got the other 2 that can go there. Now I've filled the hundreds and the ones, and I'm not allowed to repeat. So how many choices are left for the tens digit? Everybody. 1. And if we multiply those, what do we have? So we have 4 numbers. And since I know that this comes out to be such a small answer, only 4, let's actually write them out so we can see, oh yeah, that made sense. That is indeed how many we get. So let's see. I could start with 700 something, right? If I have 7 as the first one, let's see, 48 would be even. I could have 7 as the first one, 84 would be even. I could have 400 and something, and 478 would be even, but 487 would not. So those are all the 700s, the 400s, that leaves 800 and something. 874 would be even, but 847 would not, so those would actually be my 4 numbers. So everybody comfortable with that one? Okay. Now we want to find the number of even 3-digit counting numbers that are less than 400. And first question for you, can I repeat? Would something like 222 fit that description? So I could repeat 2 or some other numbers possibly. So repetition's okay. So actually I have 2 restrictions I do need to worry about. Who can tell me one of those 2 restrictions? Jack? So one restriction is that it now has to be less than 400, and I'm doing 3-digit numbers. Does less than 400 affect the hundreds, tens, or ones digit? Where do we see that restriction? Is that going to make a difference on what we pick for the hundreds, the tens, or the ones? Abby? The hundreds. So what are my choices going to be for the hundreds digit if it has to be less than 400? And why can't it be 4? Because it's not less than or equal to 400. So this can be 1, 2, or 3. Why can't it be 0? 0 is a digit, Morgan. It would really just be a 2-digit number if it started with a 0. So we have 3 choices for less than 400. What's my other restriction in this particular problem, Kyle? And does that affect hundreds, tens, or ones? Okay, so it needs to be even. So what are my choices for the ones digit if it needs to be an even number? What do we get there?
Oh, never mind. It's all even numbers.
So what does that mean specifically? Name them for me.
2, 4, 6, 8. And 0.
And 0. So we could have, that's why I want us to name them, 0, 2, 4, 6, or 8. So how many choices for something to be even? 5. Do we have any restrictions on the tens digit? So how many choices do I have for the tens digit, Kinsley? 10. 0 up to 9. So we'll put our 10 in there that's not restricted. So how many numbers altogether? 150. And is it okay if I do not list them all out on this one, since there are 150 of them? Okay, my last 2 examples are going to be kind of stranger ones, but you are going to see ones like these in the problem sets. So we may have something like we've got some people that are going to be in a line, and 2 of them refuse to sit by each other, or in this case 2 of them insist that they have to be beside each other. So I don't know, maybe this is at graduation, and since Mr. McWhorter does all of the planning and Mr. Griffin's the principal, maybe they want to make sure they're seated together on stage in case there's any question that comes up, so they can, you know, consult with each other without totally distracting everybody in the entire auditorium or something. Or maybe it's one of your pep rally skits and games, and they don't know what they're getting into, and they feel safer if they're together. We don't know the reason for it, but we know that we have some sort of a line with 4 seats. So one of the things we have to decide is, the restriction is Mr. Griffin and Mr. McWhorter want to sit beside each other. So we have to decide which 2 chairs are they going to be in. They might be in these 2 chairs, or they might be in these 2 chairs, or they might be in these 2 chairs. Any other 2 chairs they could pick that are together? So how many choices do I have for which 2 chairs? Okay, so I have 3 choices, so 3 ways to pick the 2 chairs. Okay, so let's suppose we've picked one group of those 2 chairs. How about these 2 on the left, just to talk it through? How many ways are there that Mr. Griffin and Mr. McWhorter can sit in those 2 chairs? It can either be Mr. McWhorter on the left and Mr. Griffin on the right, or the other way around. So 2 ways for M and G to fill that block. Okay, so somewhere up there out of those 6 ways now, we have Mr. McWhorter and Mr. Griffin seated. Okay, is that everybody? We still have 2 more people that need to take seats. How many empty chairs do we have? We've picked a block of 2. I don't know which block, but we've picked a block. Mr. McWhorter and Mr. Griffin have taken their seats. How many seats are left? And how many people to fill them? So then these will be this will be back to normal now. These will be our remaining seats. They might be together. If Mr. McWhorter and Mr. Griffin are in these 2 on the left, we might be talking about these 2, or we might be talking about the first seat and the last. I don't know where these 2 empty seats are. I've taken care of the restrictions first. All I know is I've got 2 empty seats left, 2 choices for whichever one I decide to fill first, and then 1 choice for what's left, for a total of 12 ways. That makes sense? If you can do some grouping like that of some categories, it's a lot less writing, a lot less space than if it's like, I don't know anything else to do, so I'm going to start making a list. You can do a list if all else fails, but it's easy to miss one of them, and it's going to take up a lot of space and a lot of your time. So try to look for categories on these things. Okay, one last example. We've got some books, and we're going to put them on the shelf. And these math books do not look identical. Maybe it's just their book number. Maybe it's book number 19-1 is a different book from the same Advanced Algebra 3 book that's got the book number 19-2. Be a little bit easier if we think of them as, oh, the math books are Algebra 1, Algebra 2, and the green advanced math book, so we can easily tell them apart. And the lit books, maybe it's something they use in 8th grade, 9th grade, on up to 12th grade, so we have 5 different ones. So I can't just jumble them around. I can't do lit, math, lit, math. I've got to do all of the math books together, all of the lit books together. So let's start with the math books. If I have 3 math books, how many ways are there that I can arrange them? Who can help me with what numbers I need to use to figure that out? Ailey, you want to give that a try? If I'm trying to arrange 3 math books, how many ways do I have to do that? And how did you get 6? So 3 times 2 times 1, we had 6 ways that we could put just the math books in order. Okay, let's think about the lit books. And I'll have what, 5, 4, 3, 2, 1. And if you guys just told me 3, 2, 1 multiplies to 6, 5 times 4 is 20. What do I have altogether? 20 times 6. I have 120 ways for the lit books. So I can put my math books, then I can put my lit books, and I have what, 720 ways to do that. Does that take care of everything? Is that the only way I can have the math and lit books on the shelf with the math books together and the lit books together? Ava, are you shaking your head no? Why? Nothing said that the math books had to go on the left. How many choices do I have for which group goes on the left? So I have 2 choices for which group is on the left. So that means I have 2 times 6 times 120, or 720 times 2, 1440 altogether. I think that's right. That makes sense? So it's I think some of them are kind of fun puzzles to try to come up with a strategy for. It's not always exactly the same kind of thing, but it is consistent. What's restricted? What are the conditions? How can I account for that? Figure out the restriction part first, and then see what that means for everything else. All right, we're going to stop there. I'll give you the homework sets, and we will go ahead and start working on our test corrections too.